So we're gonna start our first unit uh, doing algebra, okay? So algebra, again, you're gonna see it all the time when you're doing math, and most of the time it's solving for value, solving for an unknown so you can find what that value to make your equation true, okay? So let's see what our goal is for this lesson. So for this lesson, we are going to solve for unknowns, and then we're going to be checking solution to algebraic equation. Okay? So this is the goal of this lesson. So just to start, what's an equation? An equation is, it's like a mathematical sentence with an equal sign inside of it, okay? So in order for us to call it an equation, we must have an equal sign. And we have two sides. We have the left side and we have the right side, okay? So in an equation, you must think about it as a balance. Okay, where you have two sides. On each side, you want to have the same thing. Okay, in order for the balance to be balanced, the value on the left must equal to the value on the right. Okay, when we're talking about equations and solving equations, okay, so let's say if I come and I add another sugar cube to this side. Can I just do it to this side and keep the equality the same? What happens here if I do add another cube here? What's going to happen to the balance? Is it going to stay equal? What's going to happen? Which way is it going to tilt? It's going to tilt to the left. Yes? Yeah, because then I have 3 cubes here instead of 2, right? What do I need to do if I'm going to add 1 to this side? What must I do to this side? Add another one. So whatever I do to the left, I have to do to the right. Yes? Yes? Now, what if I decided to eat one of these sugar cubes? I have to eat 2, 1 from each side. Otherwise, my balance is going to tilt, right? So whatever I do to one side, I must do to the other side, okay? And this is what happens in equations, in mathematical equations, inequalities. If I do something to one side, I have to do it to the other side, okay? So your goal is to move all your terms, move the letters, keep the letters one side, and keep the numbers to the other side. Okay? So, you need to get all the terms with the variables to one side, and the constants, so the ones without any letter, to the other side. Now, it does not matter which side you choose for the isolation of each. So here's what we're going to do. The question says, solve each equation algebraically and check your solution. Okay? So I'm going to write the first one. So can you read the first one for me? So minus 4, take away 7a. Okay. So it's asking me to solve for the equation. If I want to solve, I want to know what value of k I have to have in order for this equal sign to be true. Okay? So what I want to do is I want to move everything, all the letters, all the terms with the variable, the letter k, to one side, and all the constant to the other side. Okay? Now, which side do you want to move the k's to? You want to move them all to this side or to this side? Doesn't matter, right? What I usually like is I like to look at the coefficient, and then the one with the higher number, the higher value, I move them toward it. Okay? So in this case, I have a -7, and in this case, I have a 1. Which one is bigger, 1 or -7? 1 is bigger, right? So I move this over here. Okay? When you move a term from one side to the other side, what happens to it? It changes sign, right? Because what's the opposite of negative? Positive, right? So because I'm moving that -7k to this side, right, I'm changing its value. I'm changing its operation. Okay, it's the opposite operation. So if it's subtraction, when I move it over, it becomes addition. Are we okay with that? Okay. The reason for that is this. Eyes on the board for a second. Don't write this down. I want to get rid of that -7k. To get rid of a -7k, what do you do? To get rid of a -7, you add 7. Yeah? Because what's -7 plus 7? 0, right? So in order for me to get rid of that -7k, I'm going to have to add 7k. Remember with the balance, anything I do to one side, what do I have to do to the other side? The same thing, yeah? If I add 7k here, I must add 7k here. So what happens is, this cancel, right? And I'll be left with 7k here. Now, what I was telling you is I was telling you this. I was telling you that I want to move this over, and once I move this over, because it's a negative, it's going to become a positive. Now look at this one and this one. Are they the same thing? Are they the same thing? Yeah, right? This is -4. This is gone. So it's -4 equals to 12 plus 1k plus 7k. I have -4 equals 12 plus 1k plus 7k. They're the same thing. Now this is, I did exactly the same thing, but in two different ways. Which way do you guys prefer? Do you prefer moving it over and changing the sign? Or do you prefer to do the opposite operation like this? Which one do you guys prefer? The top one? Do you guys prefer that? I can do that. Okay. So, here we go. If I do that, then this is what I get. I get -4 equals 12 plus 1k plus 7k. Now, if you look on the right side right now, I have 12 plus 1k plus 7k. 12 doesn't belong there because it doesn't have the letter k. To get rid of the 12, what do I do? What's the opposite of plus 12? -12. So I have to subtract 12. I have to do that both sides, yes? Because whatever I do to one side, I have to do to the other side. Okay? So what happens here is I have 12 minus 12, so they cancel each other. And what I have left is -12 minus 4 equals to 1k plus 7k. Now you see that I only have k terms on the right side, and I only have constant term to the left side. Do you see that? So The reason for that is because I can add like terms. Okay? Negative 12 minus 4 gives me, what's negative 12 take away 4? Negative 16. 1k plus 7k. Good. Now k is not by itself yet. K is still multiplied by 8. What do I need to do to get rid of that 8? What's happening between the 8 and the k? Addition, subtraction, multiplication, division. What's happening? Multiplication. If I want to do something opposite than multiplication, what would it be? Division. So that means to get rid of that 8, I have to divide by 8. When I do it to one side, I have to do it to the other side. So that here, they cancel each other. Negative 16 over 8, that's negative 2, equals to k. And that is my answer. Remember that my goal is isolate for the letter okay, and I did. I left the letter by itself and I found its value. So k is equal to negative 2. Now, how do I know that my answer is correct? How do I check my work? Because the question says solve and check. My original equation was this. Yeah? That was my original equation. Okay. Now I know that k is negative 2. That's what I solved for. Okay? So by replacing k with a negative 2, right? And I have to check if the left side is equal to the right side. So I plug in negative 2 for k. So that gives me negative 4 minus 7 times negative 2, because I replaced k with a negative 2, equals to 12 plus 1 times negative 2. Okay? So I replaced the k value with negative 2. The k with negative 2. So let's evaluate the left side. BEDMAS says, what do I have to do first? The brackets is already done, so I have to multiply. Okay? So negative 4, that gives me positive 40. That gives me 12. 1 times negative 2 is negative 2. What's negative 4 plus 14? 10. What's 12 minus 2? 10. You see how my left side is equal to my right side? That means I have a balance, right? That means my solution is correct. So left side is equal to the right side. So that means I have the right answer.